Now in number systems, basically there are a lot of things that we can learn. So let me just explain to you. That will be a little bit of revision and then we will move on. First, if you talk of any number, suppose we talk of 798. Now, do you understand that 798 basically is a hierarchical arrangement wherein we say that this is the units place, this is the tens place, and here is the hundreds place, right? So there is a hierarchy of these digits. This 8 is the unit, so 8 into 10 power 0 plus 9 into 10 power 1 plus 7 into 10 power 2, right? So this is how you get it. Or we can say that this is equal to 8 plus 90 plus 700, so that when you add all of them you will get 798, right? So this is how you make the digits. So this is the units place, this is the tens place, and this is the hundreds place. Now if I take this number 798 and suppose I divide it by 10, the first remainder that I get is 8. Then the quotient is 79. If I take 79 and again divide it by 10, I get a remainder of 9. And then again the quotient is 7. So if I take 7 and divide it by 10, again I'll get 7. So the number that we are talking of is 798, right? So successively, when the number is successively divided, when the number is successively divided by 10, we get the different digits as the remainder. We get the different digits. We get the different digits as the remainder, right? So if we take 8, 5, 4, 6 and divide it by 10, so basically this is equal to 8 into 10 power 3 plus 5 into 10 power 2 plus 4 into 10 power 1 plus 6. So when I divide this by 10, this will be my first remainder. Then I'll get 854. Then when I take 854, I'll get this as my second remainder. And again, I'll get this as a third remainder. Then I'll get 8 as my final remainder, right? So when I take the number and successively divide by 10, we get the different digits as the remainders. Do we understand this? This is a simple concept. You have learned this in your lower classes. Basically, what we have to understand is that we use a binary system. We use a binary system where 10 is the base. Where 10 is the base. So every digit is to the next power of 10. So this is a 10 power 0, this is a 10 power 1, 10 power 2, 10 power 3, and so on. Do we understand this? Can you make some small notes? So if I say 8, 4, 7, 2, 1, 9, so this is equal to 9 units plus 1 tens plus 2 hundreds plus 7 thousands plus 4 10,000s plus 8 lakhs. Yeah, or this is equal to 8 into 10 power 1, 2, 3, 4, 5 plus 4 into 10 power plus 7 into 10 power plus 2 into 10 power plus 1 into 10 power plus 9. So now when I divide this by 10, this is my remainder first. When I divide this by 10 again, this is my remainder. When I divide it by 1000, this is my remainder. I mean, see, first 10, then again 10, again 10, again 10, again 10, again 10. So these are the successive remainders. Okay. Now, if I want to convert number from one base to another, this is what I have to do. Suppose I have 8417 I want to convert this to the base 9. I want to convert this to the base 9. What do? I basically divide this by 9. So 9 will go 9 times 81, 31. 9 will go 3 times 27, 47. 9 will go 5 times 45. 2 is the remainder. When I take this number and again divide it by 9, I'll get 1, 0, 4, 8 is the remainder. Again, when I divide it by 9, I'll get 1, 1 and 5 is the remainder. Again, when I divide it by 9, I'll get 1 here and 2 is the remainder. So, if I want to convert 8417 to the base 9, it becomes 12582. Primarily, see, when I'm dividing, okay, first if you understand this, then I'll explain everything. So this is equal to 2 into 9 power 0 plus 8 into 9 plus 5 into 9 squared plus 2 into 9 cubed plus 1 into 9 power 4. This is how you convert number. This number is to the base 10. We are converting number from base 10 to base 9. I'll explain again. Suppose I have a number 18742. I want to convert this to the base. Let's say this is to the base 10. I want to convert it to the base 9. What do? So I take 9 and divide this by 9. So I'll get 9 into 218, 0, 9872, 9 2s 18, 4 is my remainder. Again I take 9, divide it, 9 2s 18, 28, 9 3s 27, 12, 9 1s 9, 3 is the remainder. Again I take it, divide it by 9, 9 2s 18, 51, 9 5s 45, 6 is the remainder. Again I divide it by 9, I'll get 9 2s 18, so 7 is my remainder. So when I take 18742 and divide it successively by 9, the remainders are 43672. So you arrange these in reverse order, you get the number to the base 9. So it is 43672. So this to the base 9 is equal to 18742. Okay, can you just spend a few minutes trying to make some notes? This is true not just for 9, any base. Can you just think about it for a few minutes? So I am taking the number, I am dividing it by 9. Whatever remainders I am getting, if I just arrange them, it becomes this old number to the base 9 is that number. Okay, so if I have 27634 to the base 9, what does it mean? It means 4 plus 3 into 9 plus 6 into 9 squared plus 7 into 9 cubed plus 2 into 9 power 4. So if I divide this number by 9, this is my first remainder I got. Then the quotient will be 3 plus 6 into 9 plus 7 into 9 squared plus 2 into 9 cubed. When I divide this by 9 again, this will be my remainder, and I will get 6 plus 7 into 9 plus 2 into 9 squared. When I divide this by 9, again this will be my remainder, and I'll get 7 plus 2 into 9 When I divide it by 9, again this will be my remainder, and I'll get 2, and when I finally divide, I'll get this. So exactly what I got here. I basically want you to look at a number from a different perspective. A number is basically an hierarchical arrangement of digits to a base, which means that it is 3 plus 2 into 7 plus 1 into 7 squared. So here the base is 7. Generally, when we write, we always write it to the base 10. So it is 1 plus 4 into 10 plus 9 into 10 squared. Okay. So it should not baffle us, or it should not confuse us if the base is changing. So if we agree, we can always talk on the base 9, or talk on the base 6, or talk on the base 5. Computers always talk to the base 2. So whatever you give, it will convert it to the base 2, and they'll talk only in terms of 2. Okay. So here are certain works for you. I want you to do this work and then send it to me. This is my number. All of you have Ranjit sir's number also. So I want you to make sure that you are writing this down and you are sending it to me. So the first question is, convert 872, this is to the base 10, convert 872 to base 7. Second, convert the following to base 5 and 9. A 424, B 729, C 30125. I want you to convert these numbers to the base 5 and to the base 9. If you are still not worried, if you're still worrying how to do it, I will do one more question for you. First, make a note of this homework. Convert 872. All these numbers are to the base 10. You have to convert it to the base 7. Here, these three numbers, you have to convert it to base 9 and base 5 and base 9. This is my number. You have to put a WhatsApp to me with your answer. Just write on your sheet of paper, just write your name and work it out and take photo and send it. Okay. So the way we go ahead with it is this. Suppose I have 81914. I want to convert this number from base 10 to base 6. So what will I do? I will divide this number by 6. So 6 into 1 is 6, 29. 6 into 4 is 24. So 51. 8 into 6 is 48. So 34. 5 is 30. So 4 is the remainder. Then again I divide it by 6. 6 into 2 is 12. 28. 6 into 4 is 24. 45. 6 into 7 is 42. So 3 is the remainder. Again I divide it by 6. So 6 into 4 is 24. 6 1 6. So 1 is the remainder. Again I divide it by 6. So 6 6 is 36. So 5 is the remainder. So again I divide it by 6. So 0 is the remainder, 1. So the number is 105134. Okay. This is equal, this to the base 6 is equal to 8914. 8914 to the base 10. Okay. So this is how a number can be converted from one base to another. by successive division, and then arranging the remainders. Yeah, can you make a note of this? Basically, maths is nothing, it's not a set of formulas. No. Okay, it's your ability to look at things in a different way. It's your ability to see how you can quantify something, give it symbols, and then look at it. That's why we are thinking about numbers in a slightly different way. We just want to challenge our mind. Okay, then suppose I have a number 564. I want to convert this to the base 2. I divide it by 2. I'll get 282, remainder 0. Again divided by 2, 141, remainder 0. Again divided by 2, 70, remainder 1. Again 2, 35, remainder 0. Again 2, 1 is the remainder, 17. Again 2, 1 is the remainder, 8. Again 2, 0 is the remainder, 0 is the remainder. Again 2, 0 is the remainder, 1. So 564 is equal to 1 0 0 0 1 1 0 1 0 0. So this is to the base 2 and this is to the base 10. So this is how I can convert a number from base this to base this. Okay, so I hope you are able to understand this. Yeah. Now one small observation. See, when I wrote numbers to the base 6, what were the digits that have been used? 0, 1, 2, 3, 4 and 5. Huh? When I used numbers, when I wrote number to the base 2, 0 and 1. So how many digits have been used? 2 digits. How many digits have been used here? 1, 2, 3, 4, 5, 6 digits have been used. If you see here, when I was converting numbers to the base 9, what are the digits that have been that could be used? 0, 1, 2, 3, 4, 5, 6, 7, 8. Basically, these are the remainders when any number is divided by 9. There cannot be no other, there cannot be any other remainders. So if you are writing a number to the base, if you are writing a number to the base say 9, we are using 9 digits. If you are writing it to the base 10, we are using 10 digits. If you are writing to the base 2, we are getting 2 digits. Okay, now I am asking you, suppose I take some number, let's say any number for that matter, any number n, and divide it by 6. How many possible remainders can I get? Do you see that I can get a remainder 0, 1, 2, 3, 4 and 5? If I take any number n and divide it by 7, what is the remainder that I can get? All these are integers, okay? I'm not talking about fractions or decimals. So I can get 0, 1, 2, 3, 4, 5 and 6. So here if you see there are 7 numbers. Here if you see there are 6 numbers. Yeah, can you make some notes? So these are all nice observations that we have. Yeah, you already know all these things. These are not new things, just that we are talking about it right now. Okay. So if you know, now I just want to test whether we know multiplication, addition, subtraction and all that. So I'll just give you some small questions for addition. You will have to do them. Okay. Suppose I have 456 to the base 7 plus 435 to the base 7. You have to add them. So add the following numbers to the base 7. I have 456 and let us say 435. So I'll add them. So if I add them, I have 6 and 5. 6 plus 5 is how much? 11. But that is 11 to the base 10. So I can't write 1 here. So what should I do? 11. So 11, I should write this as, when I divide it by 7, 11 will become 7 plus 4. So I write 4 here and carry over 1. So here I have 5 plus 3 is 8 plus 1 is 9. So 9 is 2 more than 7. So I'll get 2 here, carry over 1. So 4 plus 4 is 8 plus 1, 9. 9 is again 2, so 1. So when I add 456 and 435, these are numbers to the base 7, I get 1224. Do you understand? Can you spend a few minutes on this? I am just trying to see how open your mind is. I know you all know addition to the base 10. I just want to check whether your mind is open to use the same thing for any kind of addition. If you have 464 and 792 and you want to add them, here you will simply add them. 4 plus 2 is 6, 9 plus 6 is 15 because it is 5 more than the base. So 5 carry over 1. So 11 plus 1, 12, 2 more than the base. So you write it down. So these are numbers to the base 10. Now I want to see if you can do the same to 865 and 448. These are numbers to the base 9. So the following numbers are to the base 9. Add them. Add the following. Which are to the base 9. So add them up. So how will you add them up? 8 plus 5. 8 plus 5 is like 13. 13 is 4 more than 9. 9 carry over 1. 11, 2 more than 9. 2 more than 9. Yeah, 2 carry over 1. 12 plus 1, 13. So 4, 1. So the answer is 1424. So 865 plus 448 is 1424. Yeah, these are numbers to the base 9. So we are adding numbers which are to the base 9. Okay. So 3 more questions for you as homework. This is subtraction, okay? This is addition, this is subtraction. Okay, add the following numbers. So this is addition here. This is subtraction, addition, subtraction. Kindly do this. Do it on a white sheet of paper. Send it to me. I'm not expecting all of you to understand. If all of you understand, great. But if you have not understood it, don't worry. It's my job to explain. So don't think that you have to give only right answer. Whatever you understand, you explain. If you want me to do a subtraction, I'll do one subtraction. Suppose I have this number to the base, let's say 9, and from this number I want to subtract this number. Okay, what do I do? 8 minus 4 is 4. This I'll bring 1 from this side. When I bring 1 from carry over 1, it is not 14. When I carry over 1, I get 8. So 8 into 8 plus 4 is 12. 12 minus 6 is 6. So this will become now 0. When I carry over, it is it is, oh, I'm making an error. These are numbers to the base 9. So 81481564. So 8 minus 4 is 4. Now when I'm carrying over, 9 comes. 9 plus 4 is 13. 13 minus 6 is 7. So this is 0. When 1 carries over, 9. 9 minus 5 is 4. This will become 7. 7 minus 1 is 6. So the answer is 6474. So understand that when you had 10 and when you were carrying over, 10 was coming. Now if the base is 9, these are numbers to the base 9. So if 9 is being carried over, it will be 9. So here I am working 8. So when you carry over, it will come as 8. Right? So just try to do it. Don't worry. Just try to do it. Then I'll explain to you once you've done with it. So there I'd given you 4 questions. Here I'm giving you 4 questions. Right? Okay. So, so this is all. I could not have given you addition, multiplication and all with normal numbers. So I just gave this exercise so that we are not, I'm sure all of us have revised multiplication, division. Oh, I can give you another question to test your multiplication, or yeah, convert the following to the base 10. So 8491. This is to the base 12. 7142. This is to the base 9. 124 to the base 16. Yeah, can you please do this? Convert. This is also homework. So the way you do it is on your notebook. Please write it. Write your name. Work this out and then take a photo and send it to me at this number. Okay. So 8491 to the base 12. 7142 to the base 9, 124 to the base 16. If you want some help in this one, I'll tell you this is 4 into 16 power 0 plus 2 into 16 power 1 plus 1 into 16 squared. So 4 into 16 power 0 is 4 plus 2 into 16 is like 32 plus 16 squared. 16 into 16 is 36, carry over 3. So it is 256, right? So 256. So if you add all these numbers, you will get 124 to the base 16 is equal to so much to the base 10. So this becomes 36. So it becomes 292. So this is 292 to the base 10. Yeah. So I did one for you. So there are only 2 more questions for your homework. Okay. So what I've been trying to tell you is whenever you see any number, say 84321 to the base 10, this is a hierarchical arrangement. Hierarchy means as you go from left to right, their significance increases, the face value increases. So in the first case you had 10 power 0. In the second case you had 10 power 1. In the third case you had 10 squared. In the fourth case you had 10 cubed. In the next case you will have 10 power 4, right? So the hierarchical value of the number kept on increasing. 8 here is 8 into 10 power 4, but 8 here is only 8 into 10, right? So as you as it goes from, as you go from the right to the left, the place value increases. And I am saying this is true not just for 10, this is true for number to any base. So I hope you all have understood. So what you should have understood is numbers can be expressed to any base. Second, numbers Numbers can be expressed to any base. Yeah, that's it. So then you should have learned how to convert from base 10 to any number. Then 3, convert from any base to 10. Then in the process, we also learned about addition, multiplication. Also, I gave you a homework about subtraction. So I hope all of us know this. Now let's go ahead and then let's do a little bit more based on this. Now suppose I give you a number. Suppose I give you a number 89971. Okay, and this is to the base base. Let me say 10. If it is to the base 10 and I ask you, is this odd or even? You can tell me immediately. You will say that look at this 1. So it is an odd number. Now suppose I write this. Is this an odd number or an even number? Suppose I have 74371. Is this an odd number or an even number? So we should not jump to conclusion. Just because there is a 1 here, it doesn't mean what it is. So what we have to do is we have to first understand that this is equal to 1 plus 7 into 9 plus 3 into 9 squared plus 4 into 9 cubed plus 7 into 9 power 4. So when you have all this, do you see that this is an odd number? Do you see that this is also an odd number? And this is also an odd number. This is a even number. This is a odd number. So when you add up 4 odds, what will you get? You will get an even number. So do you understand that this is an even number? And how did you try to identify? You counted the number of odd digits. Odd, 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 odd. So there were 4 odd digits. So if there are 4 odd digits, when you add them up, it will become even. So this number is a even number. So whether it is odd or even also depends upon the base. Because the base is 9, you did this. Suppose I had 74371 to the base 8. Now it will be 1 into 8 power 0 plus 7 into 8 plus 3 into 8 squared plus 4 into 8 cubed plus 7 into 8 power 4. Look, all these are even numbers. There's only one odd number. So this will be an odd number. Yeah. So odd or even also depends upon the base of the number. Odd or even also depends upon the base. If the base is even, then I look only at the last digit, because all these numbers will have some even number being multiplied. If the base is odd, then I look at the number of odd numbers. If the number of odd numbers is even, then it becomes even. Do you understand this? Can you make some notes? How to identify if a given number is odd or even. How to identify if a given number is odd or even? So it depends on the base. If it is to the base 10, you know, very easy, look at the last digit. But we said there can be numbers to other bases also. So if numbers are there to other bases, we'll think a little and then we will try to write the number in the expanded form. Once we write the number in the expanded form, we will look at it, how many odds are there, how many evens are there, and from there we'll be able to say. Okay, so I hope you are clear about this. So make some notes. So if you look at all these things, numbers are very, very interesting. Okay, and maths is also very interesting. Basically, we have to understand that maths is not a set of formulas where we learn if we have to do this, if we have to do this. No, there are no rules. There are logics, and we have to understand the logics and work with the logic. So we should know why we are doing what we are doing. Okay. So if you understand this, then let's move on. So you have learned so much about numbers. You know prime numbers. Prime numbers are those numbers which have exactly two factors, one and the number itself. Every other number is a composite number. And you also know that composite number, every composite number is made up of primes. Do you know this? Yeah, how do you know this? Factorization. That's what you do when I say ask you to factorize. Suppose I give you any number 3600. So you will quickly factorize it and you will tell me that look, 2 1800, again 2 900, again 2 450, again 2 225, again 3 will give you 75, again 3 will give you 25, 5 will give you 5. So you'll say 3600 is equal to 2 into 2 into 2 into 2 into 3 into 3 into 5 into 5. So you'll say it is equal to 2 power 4 into 3 squared into 5 squared. So it consists of all these are prime numbers. 2, 3 and 5 are the prime factors of 3600. And you have taken 4 of these primes, you have taken 2 of these primes, and you have taken 2 of these primes. And then you have constructed a number, and that number is 3600. Can you work it out? Can you also factorize these numbers? 2400. Do it now. 4900. Yeah, factorize these numbers. The way I expect you to do it is, I expect you to say that 2400 is 8 into 3 into 100. So it is 2 power 3 into 3 into 2 squared into 5 squared. So it is 2 power 5 into 3 into 5 squared. This is my expectation. This is not my expectation. This is, everybody should know how to do this. But when you look at numbers, I think I'm expecting you to do this. You guys are all ambitious guys. Tomorrow you want to do well in a JE or a NEET exam. Well, though NEET it is not maths, but still we have to use our brain power and we have to work. So 4900 is 7 squared into 2 squared into 5 squared. So this is 749 into 100. 100 is 2 squared, 4 into 25. So 7 squared into 2 squared into 5 squared. So 4900 will be equal to this much. So these are the prime factor. This is the prime factor notation for 4900. Yeah, so any set of numbers that I give, you should be able to find out the prime factors for that number. Say for example, you can try to find out the prime factors for 720. Then you can try to find out the prime factors for 564. Then you can try to find out the prime factors for something like let's say 800. Yeah, so This is it. And what you know is any number will be prime number 1 to the power a, prime number 2 to the power b, prime number 3 to the power c, and so on. So any number will be of this format. Then if the number is of the format prime number 1 to the power 1, it's a prime number. Yeah, so that's what we already know, right? So any number that I give, you can quickly factorize and then tell me how you got that number. So the logic that we are saying is this, that we have some numbers which are called prime numbers. Prime numbers cannot be divided by any number other than 1 and itself. Or I can say a prime number is a number which has only 2 factors. What are those 2 factors? 1 and itself. On the other hand, you have composite numbers which are made up of more primes. So you take primes and then you keep multiplying them, you get composite numbers. So 15 is a composite number, 5 into 3. 10 is a composite number, 5 into 2. 8 is a composite number, 2 into 2 into 2. So like this, if you take primes, you can construct bigger and bigger numbers. Okay, so this is also simple. I am sure you will understand. Okay, great. We are not learning anything new. We are seeing all those old things that you have already learned. We are seeing it in a new light. We want to view it in a different way. Basically, we want to complicate it because now we are growing up and then we are expected to know more. So the simple things that you have learned as rules, we are complicating it and we are learning the same thing. Okay, now if you know all these things, okay, you make notes. First you finish writing it down. Yeah, so if you have learned all these things, now what I want to do for you is I want to ask you a question. And this is my question. I have a basket. I have a basket. This basket has 5 mangoes. This basket has 5 mangoes. In how many ways can I pick some fruit, some mangoes from this basket? So I have this basket here. This basket has 5 mangoes. In how many ways can I pick some fruit? I mean, I will be picking up mangoes, obviously. So in how many ways can I pick up mangoes? Yeah, just think about it and make some notes. Yeah, so you may say it is very simple, sir. I may pick up 0 mangoes. I may pick up 1 mango. I may pick up 2. I may pick up 3. I may pick up 4. I may pick up 5. So there are totally 6 ways of doing it. Did you get this? I have a basket. There are 5 different mangoes. You asked me to pick some. I don't like anything, so I didn't pick anything. Then there was one ripe one. I liked it. I picked it up. Then I love mangoes. I picked all of them. Yeah, so I may pick up 0. I may pick up 1. I may pick up 2. I may pick up 3. I may pick up 4, or I may pick all of them. So do you understand that there are 6 ways of treating the mangoes? Yeah, so I hope you are able to understand this. Now I have the same basket. I have the same basket, but in this I have 5 mangoes and I have 4 apples. I have 5 mangoes and I have 4 apples. Now can you tell me in how many ways can I pick up fruit? So these red ones are the apples and the yellow ones are the mangoes. And now you have given me the same basket. Now in how many ways can I pick up fruit? I have 5 mangoes and 4 apples. So a basket contains 5 mangoes and 4 apples. In how many ways can I pick fruit from this basket? Now can you think and work it out? See, earlier when there were one fruit, we found it was quite easy. Now, see, I may pick up 0 mangoes. I may pick up 0 mangoes or 1 mango or 2 mangoes or 3 mangoes or 4 mangoes or 5 mangoes. Okay, I may do this, and I may pick up 0 apples or 1 apple or 2 apples or 3 apples or 4 apples. So here there are 6 ways and here there are 5 ways. So do you see that I could pick up things in 30 ways? Do you see that I could pick up things in 30 ways? I could do something with the mangoes, that I have six ways of choosing the mangoes. Then I have 5 ways of choosing the apples, and I can do this and this because I can take the whole basket. I can just leave one for you and take the rest. So like this, if I think, I can take 0 apples, 1 apple, 2 apple, 3 apple, 4 apple, 5 apple. Then I can take 0 of each is one way. Then I can take 1 apple, 2 apples, 3 apples, 4 apples. I can take 1 mango, 1 apple, 1 mango, 2 apple, 1 mango, 3 apple, 1 mango, 4 apple. 2 mango, 1 apple, 2 mango, 2 apple, 2 mango, 3 apple, 2 mango, 4 apple. So like this, if I count all of them, I'll get 30 ways. Do you understand this? Do you understand that because there were 5 of them, I added 1. Because there were 4 of them, I added 1 and I said 30 ways. Can you make some notes? Think about it. Okay. Now, suppose I have the same basket and I have sitapalam in it, 3. I have apples in it, 4. I have mangoes in it, 5. Yeah. Now, in how many ways can I choose fruit? Now you should be able to say it fast. How? 5 mangoes, so 6. 4 apples, so 5. 3 sitapalam, so 4. So 6 into 5 is 30. 30 into 4 is 120. So 120 ways. Can you understand this? Can you make notes? Question is, in how many ways? In how many ways can I choose? Can I choose one or more fruit from a basket which contains 3 custard apples, 4 apples, and 5 mangoes. So the answer for that is, now you should be able to say, what is it? 3 plus 1, because I can choose the custard apples. I can take 0 of them, 1 of them, 2 of them, 3 of them. So there are 4 ways of treating the custard apples. Then, and there are 5 ways of treating the apples. And there are 6 ways of treating the mangoes. So totally I'll get 4 into 5 into 6. So that is 120 ways. This includes 0 of this, 0 of this, 0 of this. Suppose I tell you, no, you have to take 1. Then what will you do? You will subtract 1. Suppose I say, no, you can't take all of them. Then what will you do? Again, you will subtract 1 more. So now whatever conditions I build in, you will also do as per that. Do you understand this? Can we make some nice notes? Okay. Now I'll ask you a question. I hope you are able to understand this. Yeah, think about it. Think about it. If you think about it, you will get it. Now I'm going to ask you a question. Suppose I have 2 2s, and suppose I have 3 3s, and I want to take some 2s and 3s from this. In how many ways can I take? Then you will say, sir, you can take the 2s in 3 ways. You can choose the 3s in 4 ways. So there are totally 12 ways. Why 3 ways for the 2s? There are 2 2s. So you may take none of them. You may take 1 of them. You may take 2 of them. So there are 3 3s. You may take 0 of them, 1 of them. So you may take 0 2. You may take 1 2. You may take both the 2s. You may take 0 3. You may take 1 3. You may take 2 3s. You may take all the 3s. Right? Now, what is this number, by the way? 2 into 2 is 4, 4 into 3 is 12, 12 into 3 is 36, 36 into 3 is 108. So I have 108, which is equal to 2 squared into 3 cubed. And if I multiply these numbers, what will I get? I'll get 2 power 0 into 3 power 0 plus 2 power 0 into 3 power 1 plus 2 power 0 into 3 squared plus 2 power 0 into 3 cubed. Then 2 power 1 into 3 power 0 plus 2 power 1 into 3 power 1 plus 2 power 1 into 3 squared plus 2 power 1 into 3 cubed. Then 2 squared into 3 power 0 plus 2 squared into 3 power 1 plus 2 squared into 3 squared plus 2 squared into 3 cubed. What is this number? 1. What is this number? 3. What is this number? 9. What is this number? 27. What is this number? 2. What is this number? 4. What is this number? 12. What is this number? 36. What is this? 6. What is this? 18. What is this? 54. What is this? 108 itself. What are all these? What are all these? Do you see that these are all factors of 108? Do you see that these are all factors of 108? So how many factors are there? We know already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do we understand this? So do we understand what have we learned? We have learned if you give me a big number, if you give me 2400, if you give me 2400, which I know is 8 into 3, 8 into 3 into 4 into 5 squared. So which is 2 power 5 into 3 into 5 squared. Then the number of factors for 2400 is 5 plus 1, 6 into 3 power 1 plus 1, 2 into 2 plus 1, 3. So 6 into 2 is 12, 12 into 3 is 36. So 2400 has 36 factors. So any number that you give, I can just look at the number, factorize it, and tell you how many factors it has. Okay. So I will stop here. This is all for you to think. In the next class, I will repeat all this again. I am sure some of us might not have understood, but I am also sure many of us would have understood. I also want you to understand that maths is not about a set of rules, but maths is about your ability to think and relate different things, right? So with that, I will leave you here. We will repeat all these things again and make sure that we'll understand. There'll be no more change of teacher or anything. So I will be doing it for you. My name is Murlidhar. I head this institute, Seekers. I started this 15 years back. I'm basically a graduate out of IIT and IIM. I teach both maths and physics. I can teach chemistry also because I have learned a lot of all these things and I've been teaching all these things. So yeah, so you will spend a lot of time with me. Please read and come. Please go through this video and come. Please ask people, please ask Chidambaram sir to make sure that the video is available to you. So you will be able to see it. Fine. Okay. So thank you. See you again next week.